Okay, so I designed this to be like if I was picking out the most important topics from this class, if you're going on to AP Calculus. I'm actually going to start on the back because that's what most of you did. So I'm going to like kind of go in the same order that a lot of you did. These are your geometry formulas. I know geometry got cut off for you guys because of COVID, but they're just basic shapes, okay? Does anyone remember the area formula for a circle? I realize this is half of that, but what's a whole circle? Go ahead and put the phones away. It's the only thing we're doing today. Oh, there is a pi in it. Pi r squared. Okay, if a whole circle is pi r squared, half a circle is 1/2 pi r squared. And these are like formulas that they don't give you. You just have to know them. So what is the radius of this half circle? 3. It's from the center. Do we know what a radius is? It's from the center out to the edge. So the radius is 3. So it will be 1/2 pi times 3 squared. I'm glad we're going over this. 3 squared is 9. And so it's going to be 9/2 pi for that area. Does anyone remember the area formula for a triangle? Good. 1/2 base times height. The base is 2 and the height is 4. So the 2 and the 1/2 kind of just cancel out. And so that would just be 4. And then what is the area of a rectangle? Length times width. I'm going to go with base times height just because that's what we wrote on this one, but length times one side times the other. So 4 times 2, so that is 8. Now, this is your unit circle stuff. You can either draw a triangle or not. Once we get to calculus, we're kind of beyond that. What you're going to do is a whole bigger problem, and then like the last step would be to do sine of pi over 6. Okay, so this is like just thrown in kind of at the end. You just have to be able to do them. Pi over 6 would be in the first quadrant. What goes across from the pi over 6? 1/2, and sine is the y value, so that will just be 1/2. If you want to draw the triangle, go for it. I'm just not going to because there's not a whole lot of space on it. All right, where is 5 pi over 6? Which quadrant? Second, and cosine is the x value. So across from this, you'd have a 1/2. The x value would be negative square root of 3 over 2. And you better believe that if it's a multiple choice question, one of the other answers will be a positive square root of 3 over 2 because they're evil. Has anyone taken an AP class this year or another year and like, you know, about the AP exam and the people that write it are evil? 2 pi over 3, that's also in the second quadrant. Across from that, you would have square root of 3 over 2. And then the x value would be negative 1/2. Tangent is y over x, or opposite over adjacent. The 2's are going to cancel and you get negative square root of 3. All right, 5 pi over 4, that is in the third quadrant. Both sides would be negative square root of 2 over 2. If you flip square root of 2 over 2, you just get square root of 2. And you're welcome to flip that and try to rationalize it. The 2's will just cancel out. Cosecant means you flip sign, so negative square root of 2 for that. All right, 5 pi over 3, that is in the fourth quadrant. Across from the pi over 3, you would have negative square root of 3 over 2. But we want the x value, that would be 1/2, and we want to flip it for secant. So if you flip 1/2, you just get 2. All right, 11 pi over 6. Here, I'll ask you guys, what quadrant is that one in? Fourth. Across from it, you would have negative 1/2, and then your x value would be square root of 3 over 2. So cotangent is x over y. And actually, that ends up the exact same as the one just above that. So negative square root of 3. These next 3, I made them your like compass points, like up, down, left, right. So where is pi over 2? 0, 1, sine is the y value, so that's 1. 3 pi over 2 is down at the bottom. 0, negative 1. Cosine's the x value, so that's 0. Pi is to the left. Negative 1, 0. Now tangent is y over x. $1 million question. Is that 0 or is that undefined? That is 0. You can't divide by 0. If 0 is in the denominator, that's when it's undefined. All right, these ones you're doing backwards. So your answer is the amount of rotation. You want your answer to have like a pi in it. So how far did you rotate if sine is your square root of 3/2? Pi over 3, perfect. All right, this one's going to be in the second quadrant. Here, I'll draw the triangle for this one so we can see it. Second quadrant, cosine is the x value. Let me darken that up a little bit. That means that the y value is 1/2, and so our angle is pi over 6. But that's not your answer. It's how far did you rotate to get there? Keep calm and know the unit circle. How far did we go to get there? 5 pi over 6, perfect. And then arctangent of 1 is tricky. The way you get 1 is when both sides are the same. Anything over itself is 1. And so that is your square root of 2/2 triangle. And so that one's pi over 4. You guys have done well with that this year, though, so I'm proud of you guys. That's been good. All right, so that's all your unit circle stuff. When I teach calculus 1, I know they're giving me calculus 2 now, but when I teach calculus 1 on day 1, I hand everyone a unit circle and I'm like, here, have fun, fill this out. So like, just be prepared because that's probably what's going to happen next year. All right, the vast majority of this first page is algebra. I'm not saying this to insult anyone, but the most commonly missed thing in calculus problems is the algebra. And I understand why. It gets nitpicky. There's a lot of steps. If you make one mistake, it kind of like cascades and sort of falls apart. So let's go over our algebra skills here, okay? And I know algebra 2 was a weird year for you. First one, when you split this, how does x squared split? Yeah, x and x, 16 would split into what? Good, and it's going to be the 2 and the 8 because we want 6 in the middle. You would need positive 8, negative 2. 8 minus 2 equals 6. I don't really expect anybody to remember this one, but we'll see how it goes. When it's the cubes, first step is you cube root both of those. So what's your cube root of 8? Like if you uncube 8. 2, good. And then the pattern is square multiply square. I always draw that because a visual kind of helps people. Square multiply square. So you're going to square the x. Multiply them together, that would be 2x, and then square the 2, you get 4. Any vague memories from like last year? Okay, and then how do you get the symbols? It is same, opposite. Did your teacher teach you SOAP? Same, opposite, always positive. So same as what's there, opposite, always positive. This last one, believe it or not, this is only 2 terms. I know it looks like the alphabet threw up on your paper, but this is the first term plus sign, and then this is the second term. It's going to be GCF. We're going to look at what do they have in common. So kind of like part by part, let's look through it. What do they both have that we can take out? An x squared and a y to the 7th, and then an x plus 1 to the what? Second, good. You have to take out like the smallest amount. That does confuse people because they're like, well, it's called greatest common factor, but the most important word there is common. It's what do they both have? All right, so that's your greatest common factor. Start a parenthesis. We're going to put what's left once we remove that. So what's left from the first term? X, and then x plus 1 squared. Perfect. Plus sign, and then what's left from the second term? All right, y to the 3rd. Oh, and that's it. Cool. Do you get why the algebra ends up being the hardest part for people? Put that phone away or I'm going to take it. It's been every class for like the last 2 weeks that I've had to say that. All right, negative exponents means that you flip it. This would be 1 over x to the 4th. So I did that one for you guys. I want you to tell me this one. How would we fix the negative exponent here? 1 over e to the 5th. E is a number. Does anyone remember about how much it is? Oh, what is it? Oh, no. 2.178, da-da-da-da. It doesn't really matter. I was just bringing that up again. As long as you remember it's a number, kind of like pi is 3.14, it's just like that. All right, here, whenever you see a squared, that means you should write it twice. It means that it is a twin. So just go ahead and write that twice. It won't hurt you at all. Just write it twice. Minus, and then this part we can do. If you square 3x, what are you going to get? 9x squared. Good, it sounds like our algebra skills are good. All right, this is FOIL, first, outside, inside, last. So the first, that would give you 9x squared. The outsides give you 3xy. The insides give you 3xy. So together, 6xy, good. And then y times y is y squared. And then you've got a minus 9x squared. I did that on purpose because what's going to happen there? Yeah, those cancel and you just get this part. Number 7 is arguably the hardest problem on this entire packet because of fractions, okay? First thing I'm going to do is rewrite this. It's 2 over x and then minus, I'm going to put the 2 over what? Like, what can you put any number over? 1. Write it over 1. Give that a hug. Now, whenever you divide by a fraction, you multiply by the reciprocal. So I stuck that over 1 as well. And I'm going to multiply by the reciprocal, just flip it over. So it would be 1 over x minus 1. That's hard. If you're like, hey, that was hard, you're right, it was. But you gotta like not give up when stuff gets hard. You gotta power through it, okay? Now to subtract, we need a common denominator, which will be x. So I'm gonna multiply this fraction by the x so that it can have a common denominator, and then we can put it all together. 2 minus 2x over x, and then times this other part. Where can we go from there? Look through. What would you try next? And hint, it'll be with this part. What do they both have? Both terms. They have a 2. Let's factor out a 2. If you factor out a 2, what will be left? There will be a minus x, but what comes before that? Good, 1. 1 minus x. Now, do you see how there's a 1 minus x and an x minus 1? They do cancel, but do you remember what we have to put whenever they're opposite each other like that? Because I can cancel them, but I have to put a negative out front. That's what allows you to flip them. So your final answer to the whole thing is negative 2 over x. And if what you're sitting there thinking is like, yeah, that's going to be a no from me, you can't do that in AP Calculus because every problem is really, really hard. There really aren't easy ones. Like you have to not be a giver upper. This is my day where I kind of am just pep talking you if you're going on to that class next year. You can do it, but you cannot be a giver upper, okay? And be scared of fractions and factoring and algebra and all. All right, number 8. Using this formula and h equals 1/4 r, write v in terms, does anyone know what this is the formula for or what v even stands for? Because this is an actual formula for something. What did you say? Okay. Oh, close. It's a cone. It is your formula for the volume of a cone. So like if you had an ice cream cone and you filled it up with water, it's like the volume that would be inside the ice cream. Well, what you're going to do is take this 1/4 r and plug it in for h. It's a substitution. If h equals that, we're going to plug it in. So you get v equals 1/3 pi r squared times 1/4 r. And then we're just going to multiply all that stuff together. So 1/3 times 1/4 would be 1. What? 1/3 times 1/4 would be 1. You're multiplying, so 3 times 4, 12. Okay, good. 1/12 pi, and now it's not squared anymore. It'll be r to the third. Good, because you have 2 here and then 1 there, so r to the third. All right, rationalizing. We did that this year. How did this go? These ones okay? I know a lot of this was probably hard. Algebra is hard. It is. This one would be what? 5 square root of 7 over 7. This one you multiply by square root of 2. So it would be square root of 10 over 2. When they're both underneath the root, you can multiply them together. All right, this next section is the most important thing we're going to do. If I could sum up like most of calculus in one word, it would be slope. It's a study of a rate of change, which is what a slope is, okay? So slope, you subtract the y values, so 6 minus -4, that'll be 6 plus 4. And then subtract the x values, -1 minus 2. So what is that? 10 over -3. All right, state the slopes that are parallel and perpendicular to 2/3. Well, parallel means what? Same, so parallel is going to be 2/3. And perpendicular, do you remember how to do perpendicular? Yeah, flip it and change the sign. It's opposite reciprocal, so it'll be -3/2. All right, using this function, find our coordinate points for 1 and 3, and then find the slopes between them. So we want 1 comma something and 3 comma something. How do we get the somethings? Yeah, plug them in. If you plug in 1, you're going to get 1 minus 5 will be -4. If you plug in 3, you'll get 9 minus 15, which will be -6. And then you're going to do the exact same thing we did in number 11, is find the slope. So -6 plus 4. And then what will go in the denominator? 3 minus 1. Perfect. So let's see, that'll be -2/2, which will actually reduce further. That'll be what? -1. All right, I wrote the format for point slope form on the board. It's y minus the y number equals your slope, and then x minus the x number. So for this one, it'll be y minus -9, so that'll be y plus 9, equals your slope, 1/2, and then x minus the x part of your point. And that's it. You don't have to do anything else to that. You just leave it alone. I know in Algebra 1, they hammer y equals mx plus b into, but we don't use that. We use point slope. This one's going to be the same thing, but you have to first find the slope. All right, so it'll be 5 minus 6, and m for slope. M is what we use for slope. And then 0 minus -3, which will be +3. And so what is that going to simplify to? Yeah, -1/3. Now, it does not matter which point you use. I'm just going to use the first one because it's the first one. It does not make a difference. Y minus 6 equals my slope. And then x minus -3, so +3. We actually did point slope form this year. It was back in unit 2. Do you guys sort of? I did cover that this year. It happened. Promise. Oh, before the SAT? Was point slope form in your lines and stuff like that? Oh, okay. The SAT is more difficult, I think, for you guys because it's on a lot of Algebra 1 and geometry, which is a lot of time has passed for you guys. I get that. Slightly familiar. I should run a SAT review session before. All right, you also have to be able to analyze graphs, which means you need to be able to know what a graph looks like. So transformation, what directions did this one move? Up 3, left 2, put a point, and then what shape is absolute value? V, okay, and it didn't get stretched or shrunk, so the slope is 1 for each side of it, 1 or -1, so you can just go up 1 over 1. See, because you're going to do things where you analyze that graph and talk about the behavior of the ends of the graph and stuff like that. So you have to be able to know what the graph looks like. All right, what shape is this one? It's the wiggle thing. We didn't move it around, so it's still centered at 0, 0. But what does the negative do? Flips it, so it's going to be upside down. So you can have points there, and it's going to do something like that. All right, let's plug in some points for this one. If you plug in 0, you're going to get 0. It's not transformed at all, so centered at the origin. What's another point we can put on that? 1, 1. And then let's get one more. 4, 2, good. What would the next one be? 9, 3, 9, 3. Does anyone remember what this is with the double bars? Steps, good. Okay, so you're gonna start at the origin, that's your first step. And I didn't transform this one, so it's just your regular old staircase. But if it had gotten stretched by 2, the steps would be 2 units apart from each other. That is discontinuous. Remember that word? We talk a lot about continuity in calculus, continuous versus discontinuous. And continuity always shows up on the AP exam. It will be on there. E to the x. I'm not really concerned about a whole lot of particular points here, but what is the basic shape? And you can do like a hand motion because that's usually what I get. Do you remember the swoop? Good, it's exponential. You're gonna have a horizontal asymptote at 0, and the only point you can plot specifically is 0, 1. And that's because anything to the 0 power is 1. So it's gonna look like this. If you are going on to AP Calc next year, keep this packet and like put a star next to number 20 and number 21. You have to know what E and ln look like. You just have to have those in your back pocket. This is e to the x. Ln of x is the inverse. So you're just going to take this and flip it. So instead of the horizontal asymptote, it's going to be vertical. And instead of 0, 1, you're going to have 1, 0. And it'll look like that. But like put a heart or a star or something next to those because those are very crucial. You will need them next year. All right, this one is piecewise and the break happens at 3. Do you remember the flip book we made and you actually took out scissors and cut it and then we flipped them? Okay, we're gonna graph 2x minus 1, but only until we get to 3. So this would move down 1, you can put a point right there. Slope is 2, so you can go up 2 over 1. But you have to stop when you get to 3 on the x-axis. Like this is where our break is gonna happen. And what kind of circle is it gonna get there? Open, good, because there's not an equal to. So an open circle right there. It looks sort of like a clock hand pointing to like 7 o'clock or something like that. But this is where like the cut is happening. All right, and then you want to just graph like x, y equals x from 3 onwards. So if you plug in 3, you would get 3. You plug in 4, you're going to get 4, 5, 5, so on and so forth. And that looks like another clock hand. But is it continuous or discontinuous? Discontinuous. And what you're going to do in calculus is you're going to look at the behavior of the graph from the left side and from the right side and showing that they do not match up. Like that's what you guys are going to analyze. You will not be able to do that unless you can graph the graph. So that's why you have to be able to do that. These two are both waves. I just usually remember where they start. Where does sine start? Origin. And then it's going to wave. And then where does cosine start? Yeah, 0, 1. Good. If you remember where they start, then you'll be okay. And I just graphed one period of the function, but obviously it goes on forever and ever and ever. They look like each other, just scooched over a bit. All right, and then here we have our graph characteristics. State intervals of increasing and decreasing for this graph. Well, you're going to kind of need to sketch it off to the side here because you have to see what it looks like. So what directions did it move? Down 5 and left 3. So down 5, left 3, and it's flips. And what shape is it since it's a squared? Yeah, quadratic, it's a parabola. It's going to look like this. If you don't want to draw that, I guess fine, but you have to like know what it looks like in your head. So increasing and decreasing, we're going to do left to right. Let's do increasing first. From left to right, we increase from where to where? Negative infinity until -3, perfect. And then we decrease from -3 to infinity. What I usually get is, but Miss Cole, the arrow is pointing down. Shouldn't it be negative infinity? No, you're going left to right. It's the right side is positive infinity. Bless you. State the domain. Who is your troublemaker? Do you remember this? Who's getting kicked out? Who is not invited to the domain party? 4. Why 4? Because that's correct. What would 4 have? If you plugged in 4, what would happen? 0 denominator, which you can't have. Do you remember how to kick out 4? How do you write it? Good. And then union 4 to infinity. Leave 4 out. 4 is causing problems. This one's really similar. We're just going to write it in a different format. Your vertical asymptote is going to be at -9. And we write it x equals -9. Do you remember Hoy-Vux? Vertical is x equals. Anyway, it's true. And what you're going to do in calculus is analyze the behavior of the graph. All right, now these next couple have horizontal asymptote. What you do is compare the degrees. In the numerator, this is 1, it's x to the 1. Denominator, it's 2. When the numerator is smaller than the denominator, it is automatically 0. Now in this one, it's a tie. Do you remember what we do when it's a tie? Good, so it'll be 3/4. Y equals for horizontal. Now to find the whole, that comes from what cancels out. So you're going to have to factor this. More algebra. I know you're all excited. It'll be x and x. How does 2 split? 1 and 2. And you want a negative x in the middle. So what is what? +1 - 2. And oh my gosh, these cancel out. So we get 1/x + 1. Now the question is, what are the coordinates of the whole? So where is the whole going to be? Well, we canceled out x - 2. So what makes that 0? 2, good. How do you get the other part? Because we're usually good up to here, and this is where we run into like a roadblock usually. How do you get the other part of the point? Can you close the laptops for me? Like, that's my rule when I'm teaching. It's the only thing we're doing today. What do you do with the 2? Yeah, plug it in. 2 + 1 is 3, so it would be 1/3. Aiden, can you just shut that for me while I'm teaching this? Aiden, can you just shut that for me? Thank you. All right, now we're going to use this graph to state the characteristics. Positive. Positive means above the x-axis. I usually call it above sea level. So that would be from where to where? Are we above sea level? -1 until 4. -1 to 4. Now, if you want to have the bracket versus parenthesis conversation, I was at a workshop once where they said when they're grading the AP exam, if it is supposed to be parentheses and you put brackets, they will mark it wrong. But if it's supposed to be brackets and you put parentheses, they will let it slide. So I was like, oh, we just put parentheses for everything then? Good. Because I'm like, I honestly don't care. Just tell me what I need to do to get the right answer. So I'm going to put parentheses for everything. All right. Negative means below sea level. So where are we below the x-axis? From where to where? -2 to -1. All right, increasing. Now you have to read left to right. We increase from -2 until where? 1, good. Union, and then where else do we increase? 3 to 4, good. Decreasing is 1 to 3. All right, relative maximums and minimums cannot be endpoints because those aren't relative to anything else. A relative maximum means that it goes up and comes back down. There may or may not be one, or there could be multiple of them. All right, does it look like we have a relative maximum, like a high point? Yes, it's this point right here. Do you remember how we write it? Because it's not as a coordinate. Good, yeah, it's like that. 2 at x equals 1. So 2 is the maximum, 1 is its location. In calculus, sometimes they ask you for the maximum and sometimes they ask you for where it's located. So that's why you need to know the difference, because sometimes the answer is this and sometimes the answer is that. Our relative minimum, that means you went down and came back up. Do we see a place where that happened? Like the graph decreased and then increased. Yeah, good, right here. It's 3, 0, so we're gonna write it as 0 at x equals 3. Now, an absolute maximum and minimum can be an endpoint, or it could be the same, bless you, it could be the same as the relative maximum or minimum. It's just the highest point, period, end of story. So for this one, the absolute maximum is the same as the relative maximum. It's 2 at x equals 1. And then what's our absolute minimum, like the lowest point, period, end of story? Good, -3, and it's located at x equals negative. All right, exponential and log stuff. ln and e do what? They cancel. This would just be 2. Do you remember the flashcards I had you do? Or what was it on Quizlet? I made up those flashcards. And then ln of 1, you do need to know that ln of 1 is 0 without a calculator. All right, solve. You would subtract over the 5, so you get ln of x equals 7. And we did one like this in the breakout that we did last time. How do you cancel out ln? Exponential, so it's e to the 7th equals x. Now, if you don't have a calculator, you just leave it e to the 7th. That's some decimal. It's like 2.1 to the 7th, whatever. I don't know what that is off the top of my head. All right, and then what would you do for this one? Add 1. And then to cancel out e, you would do ln. But what is ln of 1? Hint, I wrote it right above. ln of 1 is 0. Divide by 4, and you're just going to get 0. All right, and then geometry. A rectangular plot of land is going to be fenced in. You have 400 feet of fencing available. That's all you've got. One side is going to be against a river. Why would that be a good idea to put one side of the fence against the river? Yeah, you only need 3 sides, and also then your cows and sheep can get water and stuff, right? So here's the picture. There's the water. Here's our rectangular fence, and I'm going to call it X and Y. You can call it whatever letters you want, but I like to go with X and Y because it's just familiar to us. Now we only have 400 feet of fencing. So if you add up these 3 sides, it should equal 400. It would be X plus what if you add them all together? 2y, good, equals 400. Now it's saying write a statement for area. This is the perimeter. How would we do area? Hint, it's area of a rectangle, which we already did. Area would be what? Length times what? It's going to be x times y, but it says in terms of one variable. There's 2 variables. Do you see that? An x and a y. We want it in terms of one variable. So we're going to have to substitute something out. Which variable would be easier to solve for here? Which one's easier to get by itself? X, good. So how would you get x by itself? Subtract over the 2y. So it's 400 minus 2y. And what you do is you take that and you substitute it in for x. You're substituting in for one of the variables, so it'll just be one variable. So we get area equals. You do this in Algebra 1. Do you guys remember substitution? You got a whole year of Algebra 1, so I know that that happened. It was just like 3 years ago. And then what would you do with this y out here? Yeah, distribute. Good. So what's that going to give you for your like final answer? 400y minus, good, minus 2y squared.